So in the remainder of this lecture we will discuss a very important application of differentiation, which is in fact optimization. So finding the minimum and the maximum of a function. You will encounter this problem in a situation of where you have to compute the so-called maximum likelihood, and I want to give you an example of that problem, which we will solve later on. So what is an example of computing the maximum of the problem of maximum likelihood? It's the following situation. So we throw a coin, and we already did it before, but then we threw an unbiased, so-called unbiased coin, where the probability of head is 1/2. But now we have a biased coin, and the probability of head is equal to p. The probability of tail then necessarily is equal to 1 minus p, because the probabilities have to sum up to 1, and the game is that we get 1 if head shows up, we denote it by capital H, and we get 0 if tail shows up. We denote this by capital T. Now, if we throw a coin twice, then what will we get in that situation? Well, we get 2 if we have 2 times head, we get 0 if we have 2 times tail, and we get 1 if we have 1 times head, 1 times tail. What we will consider here is the case where we throw 3 times, and the result is that we get 2. Now, how can this happen, and what is the probability of getting 2? So, probability that we get 2 is, well, we get 2 if we have 2 times head. So this is the probability of, well, 2 times head, but this can occur in different ways. We can first throw tail and then 2 times head, or first head, then tail, then head, or 2 times head and then tail. What is the probability of throwing first tail and then 2 times head? Well, we have to throw tail, so this occurs with probability 1 minus p, and then we have 1 head and another one, so it gives us p squared. Of course, well, the probability of first throwing head and then tail and then head is not different. I mean, you have p times 1 minus p times p, and we get the same expression, and a similar argument applies to the last probability. So in total we get 3 times the same probability, which is equal to this expression here. Now we have an unbiased coin, but we do not know how unbiased. More precisely, the problem is, what is the value of p? Now, of course, we cannot know it, but we can try to guess it, and the goal is to make a good guess for p based on the information that we have. And what is the information that we have is that we got 2 in 3 throws after we threw the coin 3 times. So we have to do something clever, and the sort of standard clever idea is that the following thought: well, since we got 2 after 3 times throwing, apparently, well, we might think that the right p is the one that maximizes its probability, since we got it. Since we got 2. So we choose p in such a way that the probability of getting 2, which is in 3 after 3 times throwing, which is this expression, is maximum. Now, of course, we cannot consider arbitrary p, because p has to be a probability, so p is an element of the interval 0, 1. So what the question is, mathematical question is for what p is this function, this probability of getting 2 is a function of an unknown variable p. So for what p is this probability maximized? And of course, if we know the p for which it is maximized, we can calculate the value of this maximum. The question is, how do we do it?